interpret, then later we start solving. Question 5, when you look at the required part, they are telling us that we formulate a linear programming model for the above information. You recall our steps. We normally have 4 steps that we follow when we are formulating linear programming model. Then Roman 2, they are telling you that you generate a dual to the linear programming model in Roman 1 above. Then Roman 3, you are to use Simplex tabular method to solve what you have in Roman 2. So we can use this information to come up with our linear programming model. So you can get your book and we start. Just for purposes of recording, I'm trying to record here my linear programming model for question 5. This is question 5. And the inequality here is less or equal to. Less or equal to 750. Then the next one is 2x. 2x plus 3y. It is less or equal to what? 1,500. Then here it is 2x plus y, which is also less or equal to 1,000. And you have your non-negativity. All of them, for them, they are greater or equal to. And this is one mark you don't need to always forget. If at all you are the one formulating for yourself. So that is about question 5. I'm just drafting again. Then for question 6, we also need to come up with linear programming model. And we need to interpret our question 6. They are telling us that a factory manufacturing floor tiles is to use 3 ingredients, A, B, and C, in varying proportions to produce 3 new brands of tiles. This is a factory which is manufacturing a floor tiles. And you have 3 brands. These brands are defined O, P, and G. Remember, as you interpret, colleagues, you recall that we follow steps. We follow steps. And like now, the first step, who can remind me what is the first step? Colleagues, this is revision. What is the first step? Who want to try? We have 4 steps that we normally follow. What is the first step?
Identify and define the decision variables.
Perfect. We have to identify and define decision variables. So in this question, what are our decision variables? Remember I said, in a situation where you are confused about decision variables, first read through and identify constraints. Once you identify constraints, it can be easy for you to come up with decision variables. Because here you see, this is a factory that is manufacturing floor tiles, but they use ingredients A, B, and C. But to your mind, you should be knowing, if at all you're dealing with ingredients, what comes into your mind. Now you're also given 3 new brands of tiles. What comes into your mind between A, B, and C, between ingredients and tiles? What can be your decision variable? What can be your constraints? But at this point, if you're confused, you just first proceed. And as you proceed, what is your aim? Your aim is actually to pick where you have those words like at least, at most, available, up to, does not exceed. Those are the words that help you to actually know that what I'm talking about in this question is actually my constraint. So they are telling us that the factory wishes to produce, this factory wishes to produce at least. Every time you see that word, I say that you immediately create option 4 for the inequality. You have at least. Now, which inequality for at least? Is it less or equal to 100?
Greater or equal
Greater
to.
or equal to.
All right. So here they are saying the factory wishes to produce at least 30, 40, 50 units of O, P, and G respectively in the initial phase. So you can just do a rough work somewhere, because you're just at this point you're just trying to interpret the question. But as you do the rough work, keep in your mind that we have 4 steps that we follow. The second step should be to state the objective function. Remember, the objective function, we said that it can either to maximize profit or to minimize costs. If at this point you cannot identify also what is your objective function, you skip also this step. You go to the next. The next one is to state the constraints. Remember, in an exam, you are not doing this. You are not writing this that identify and define. No, for you, you are just answering. But you should answer as you recall that we have these steps that we normally follow. So here we are told that we have this is a O, P, and G. You have O, P, and G. They are restricted to which one? They are saying at least. At least which sign? Greater or equal to. So I can put here greater or equal to. Just I'm trying to interpret the question. For O is how many?
30.
For O, it is 30. Perfect. This is 30. The next one is what?
40.
The next
50.
next is 50. Then we continue reading our question. They are telling us that each turn of A, remember what you have. These 30, 40, and 50 are your units. But they are telling you that each turn of A, someone is asking, or each turn of A yields 10 units of O, 20 units of P, and 30 units of G. That is each turn of A. It is yielding 10 units. Then here 20 units, then here 30 units. And they are telling you that each turn of B yields 20 units of O, 10 units of P, and 10 units of G. Then you have also a turn of C yields 30 units of O, 20 units of P, and 10 units of G. Okay. How are you going to summarize your information? Now, the question is, you have A somewhere. Let me just indicate you have A and A, B, and C. I can let me just put them up. I want to show you how tricky interpreting these things can be. Now, if you put, they told us that for each turn of A yields what? 10 units of O. So you are going to put here, 10. Are you using this row or you are using column as you put those figures?
We're using column.
Column.
It's column.
Then for this one, P is how many?
30. 20.
Someone is saying, Abe, we are on question 6 or 5. It was typing error in that document, but we are on question 6. This is question 5, this is question 6. Then the last one is question 7. P is how many?
It's 20.
20.
20.
Then G
30.
30.
for B
20.
20.
is 20. Then
10.
for P is 10. You can put some speed. Then G
10.
10.
then we go to C. See, they are telling us what?
30.
30. 20.
Then next
10. 20.
here we have the last one is 10.
Yes.
Perfect. Okay. Here you have interpreted.
Yes.
You have interpreted from here up to here. Then the next one, they are telling us that given that the factory used x1 tons of A, they used x1 tons of A. Are you seeing that? Here they are trying to define. They are trying to define for you. You have x1 relating to A, then x2 relating to B, then x3 relating to C. And they are giving you that, they are telling you that the cost of each ton of ingredient A, B, and C is shillings 10. For this statement, it is going to help us to formulate our objective function. So when we come back to our objective function, it means that this time we are not going to maximize profit. Since the figures given are in terms of costs, here we are going to first, the objective function, the first objective function is should be to minimize costs. And I said to minimize costs, you can either use any letter, but this word matters. Don't claim that you should always use P. You can use K, you can use Z, but as long as this one is correct, you will be good to go. So we are, for this question, it is to minimize costs. And the first one is how much? On every ton of A costs 10 million. So I can, remember A is defined in terms of X1. So I can say 10 X1. I don't need to use X1. Let me just maintain A plus the next one is what? How much?
12 million.
This is B. Then plus the next one?
15.
15. This is C. And your figures are in millions. So it means that based on our information, since your objective function is defined in terms of A, B, C, then your decision variables can also be A, B, and C. Any question up to this stage?
Yes, me, I have a question.
Your voice is very, very down.
I have typed the question, Abe.
Yes, yes. Yes, your decision variable should be corresponding to your objective function. That's where you can actually guess it's where you can guess your what? Your decision variable. Yes. So at this point, what you have actually done is to just have your summary. But remember, we always have the last step. So before we go to last step, we normally tend to summarize here. If we are to summarize, this is 10 times A. 10 times A, that is 10A plus plus 20B plus 30C, which is was the sign greater or equal to? Yes. Then this one is 20 times A, which is 20A plus 10B. Then plus what?
20C.
20C. This should be greater or equal to
40.
40. Then the next one is 30A plus 10B plus 10C, which should be greater or equal to 50. That is your summary. Which can be reduced because when you observe, you can reduce this inequality by 10. This figure is divisible by 10, this is divisible by 10, this is divisible by 10, this is divisible by 10. So you can reduce. Someone can say this is A plus 2B plus 3C is greater or equal to 3. Then this is 2B plus B plus 2C. Are you understanding what I'm doing?
Yes.
Then
The
this
second one is
the second one is what?
it is 2A, not 2B. The second increase.
Thank you. 2A plus B plus 2C. Then here is 3A plus B plus C, which is also greater or equal to 5. Okay, then lastly, this is step 3. Then lastly, step 4. What is step 4? State your non-negativity. Non-negativity. And non-negativity, how many variables do you have based on your decision variable? 1, 2, 3. So this will be A, B, and C should be greater or equal to 0. Or another person can say A should be greater or equal to 0. Also B should be greater or equal to 0. Then C should be greater or equal to 0. The person who has done this is the same as the person who has done this. And this is your non-negativity function. So at this point, you have answered Roman 1. At this point, you have answered this Roman 1. And what you have, this model you have is called a Primal problem. The original problem is always a Primal problem. The original objective, Primal problem always indicates the original objective. Here, the original objective is actually to minimize costs. That is the objective, to minimize costs. But Roman 2, they are telling you that you generate the dual to the linear programming model. When they say you generate dual, that is your problem. It's like you are trying to convert the original objective. If the original objective was to minimize costs, if Roman 2, we are to formulate dual problem. Here, you are trying to change, changing from minimization to maximization. Because the original objective was to minimize, you are saying that the fact that the original problem, the Primal problem, was to minimize, the dual problem should be to maximize. That's why I'm saying we should be changing from minimization to maximization. But if I told the original problem was to maximize, if I told here we had maximize, then the dual problem would be to change from maximization to minimization. But that is a rare case. Sometimes we don't normally deal with that. When we are handling dual problem, most of the times you'll find that we are actually changing from minimization to maximization, especially when we are using simplex method. Because with simplex method, it normally deals with a maximization problems. Okay, so how are you going to convert from minimization to maximization? For you to convert, now it means that you will be changing, you must change row to become column. Your original row where you had inequality. That inequality, that row where you have inequality is going to become a column. And also, the next you need to change is now what was your decision variable is going to be your constraint. What was your decision variable? Initial decision variable will be now the constraint. What do I mean? Of course, we will need now to again state new objective function, and this time it will be to maximize. It would be to maximize. I can use the generator and I say max. Variable, what was your decision variable will be now the constraint, and your constraint will be your decision variable. It's like the opposite. It's like the opposite. And our constraints, let me just add it here, and your constraints will be now the decision variable. What do I mean? You see here, A, B, and C. Do you accept that this A, B, and C were our decision variables? A, B, and C are decision variables. But now we are saying, since we are changing to your problem, decision variable will be now the constraint. So it means that if I had my decision variables here, they are going to appear this side. What I had this side will be the one to appear on the top. So it means that here, like when I'm presenting, I'm going to put here A, I put here B, I put here C. Then on top, because I'm changing, now I'm changing this decision variable to become the constraints. It means that where there is A, I'm going to put O, where there is B, I put P, where there is C, I put G. This is O, this is O, this is P, this is G. Colleagues, are we together? I should be communicating. Don't keep quiet when you are not understanding something. Please feel free to ask. Feel free to ask. Don't say that I will understand later. Try to understand now. There is no time. Is everything clear at this point?
Well, the reason why you change the A, B, and C to O, P, G, it's because now you are maximizing.
Yes, yes, yes.
Okay.
It's because
okay.
I said the reason why we are doing all this is because we are trying to change the original problem, which was Primal problem. We are changing this Primal problem to dual problem. And the fact that the Primal problem, the initial objective was to minimize. Now we need to maximize. We are changing from minimization to maximization. But to do that, these are conditions. One, you must change row to become column. This is related to your inequality. This is related to your inequalities. Then, number two, condition number two is that you must change your original or your initial decision variables to be now your constraints. And what was your initial constraints will be now the decision variables. That's why you see, initially, I had here A, B, and C. These were my decision variables. I am changing these decision variables to appear as constraints. I'm changing these decision variables to appear as constraints. And how do I do that? I have to put here O, I put here P, I put here G. Then what was our constraints? O, P, G is now going to be the what? Is now going to be our decision variables. Okay, is it clear at this point?
It is.
Excuse me, Abel.
Yes, yes, yes.
What if I maintained it as a minimization? Is it wrong?
It's wrong. That will
Pardon?
be wrong. Because the concept is the original problem is always Primal problem. And if they say you generated your problem, it means that you are trying to change the original problem. If the that here your problem you have to maximize. If the initial problem was to maximize, then here our focus would be to change from maximization to minimization. Is it clear? Safira, is it clear?
Yeah, but then if at all they didn't talk about changing maybe from Primo to Duo, would we continue and use
Now,
minimization?
if they don't say that, most of times, as I say, when we are using simplex method, the concept we be having is always to maximize, especially when you are using simplex method. That is always the concept. And every time we are dealing with maximization as our objective, we expect these inequalities to be less or equal to. We expect these inequalities, these ones, every time you are handling a simplex method, you will realize that most of the time, that's just that some of you have never realized that. But every time you are using simplex method, you will realize that your inequalities are less or equal to. You will find that you are not dealing with greater or equal to. The reason is with simplex method, most of times we are dealing with what? Maximization, objective. So if they don't say you change and you realize that maybe these were greater or equal to advanced level, you may need it to change. For advanced level. Even if it is not advanced level, but just have it in your mind that when you're dealing with maximization as your objective, try to make sure that your inequalities are less or equal to. If it is minimization, your inequalities are always like this for minimization. But with simplex, we tend to solve maximization problems. Most of times, don't solve minimization using simplex. Any other question? Jim, is everything clear? Jim, is everything clear? Patricia, Mary, is everything clear?
Everything is okay, Abel. No problem. No worries.
Derek, are you good?
Yeah, we're clear.
Simon, are you following or you are watching other things but putting on the session?
Following.
Okay. So we can continue. So we are done with this one. Now we need to focus on this. What was our row is going to become the column. So you just come here. This is row. Just make it a column. This is a row. Just make it a column. So it means that here you are putting which figure? Here you are putting the figure. This is 1A. So here I'm going to put 1. Then even you can copy it from here. It makes sense from here. Like this was O, and now the original O, this was a row. Now it is appearing as a column when you check here. This is O, it is appearing as a column. So you just copy and paste. So this is 1, 2, 3. 1, 2, 3. I'm just picking those figures from here. I don't want to again reduce. This is 1, 2, 3. Then at this point, first wait. For these ones, first wait. We will talk about them. Have you understood why I'm doing this? I am changing row to appear as a column. Then we go to the next
And the reason
row.
why is it like that?
It's a rule. It's a rule. That's why I said to do this. I had to put these two rules. One, you must change row to become column. Then rule number 2, your decision variable will be now the constraint. And we have done that from here and here. And you will see why we are doing that actually. When we start bringing inequality, you will see the reason that now it is coming out clearly. Then column number 2, what will be the column number 2? You just go back at your row 2. This is your row 2. So this is 2, 1, 2. This is, I write 2, 1, 2. Then this one I also change to appear as a column. Colleagues, let's write. Let's not reduce here. Let's write the way these figures are given. This is 10. Some of you will be 10, 10, 20, and 30. 20 and 30. Then P, we have 20, 10, and 20. 20, 10, and 20. Please don't feel shy to ask. Don't feel shy to ask where something is not clear. This is 10.
Why are you not reducing them and you put them on the as they have been?
I'm going to respond to that. Let's
Okay.
first do it like this. I'm going to respond to that. But at this point, are you okay? At this point, doing this, is everything fine with all of you?
For me, it's okay.
Converting row to become a column. All right. Now, once you're done with this, we need to put inequality. We need to put inequality. So here, I left the space knowing that I will put condition number 3. Change the initial inequality if the original inequality was greater or equal to, now you are going to change that inequality to less or equal to. Like here. And how are you going to do that? The figures you had here, these are the figures you had after the inequality. These figures you had after inequality are the figures that are going to make your objective function. These ones. These ones are the figures that are going to make your objective function. Then the figure that you had here are the figures that will appear after your new inequalities. So I am changing the original inequalities. They were greater or equal to. Now I'm going to make these inequalities to appear as less or equal to. Then I said once you change the inequalities, what are the figures that will appear here? Those are the figures that you had on your original objective. You see 10, A was 10, A was corresponding to 10, B was corresponding to 12, then C was corresponding to 15. That's why you see that if I put here 10, this 10 is corresponding to A. Then if I put here B, if I put here, what was the B? This is 12. Then here it is what, 15?
15.
Perfect. Then the figures that were here initially, these figures, these ones, are the figures that will help you to formulate the objective function. So it means that on objective function, here you are going to be having 30. This 30 was corresponding to what? This, you see, this 30 was corresponding to what? To O.
Oh.
Oh,
So this is a 30 O. Then you add, next one is what?
40.
40
40 P.
Then plus, next,
50
50. Yeah. And this is your objective. This is your objective function. And you are done with the struggle. Any question here? You see, I'm very slow because I know some of it might be the first time to hear this, but once you understand, it becomes very easy to do more numbers. Let me hope it is clear to you all. Now, once you're done with that, you can now summarize your information. Summarize. This is 10 times, this is 10 times O, which is 10, which is 10 O. Then plus 20 P plus plus 30G. This is less or equal to 10. Here it is 20 O plus 10 times P, which is 10P, then plus 10G, which is greater or equal to 12. Then next is 30 times O, which is 30 O. Then plus
20 P.
20p n plus 10d, which is also less. Now, someone initially had asked that here I reduced values. And he was saying, why am I not reducing these ones? You are going to reduce an inequality, like this one can be reduced. We can divide the common factor. Even here is as a factor. Not every inequality you're going to here, you cannot, this one is. Here you cannot reduce it by 10 because this is not divisible by 10. This is not divisible by 10. So that is the reason why I said, no, let's take recording in our. That's why I said I have to take the figures the way they are. I am trying to say that here I didn't reduce the values because by 10, because not every value is divisible by 10. Like this inequality, you cannot divide everything by 10. Like this inequality, you cannot divide everything by 10. So it is good now to work in this way. What about now? Are you now getting me, or it is still bad?
Yeah, it's clear now.
Okay, okay. Any question? Because we are done, we are left with put here non-negativity. And with non-negativity, remember we form non-negativity based on your objective. The objective is in terms of what? O, P, and G. Recording in. So this is O, P, G, or should be greater or equal to 0 as your non-negativity. And that is your Roman 2. That's all about Roman 2. This is your problem. Any question about your problem? We have actually answered this one. And Roman 3, they are saying use simplex method to solve your problem. You are not solving Roman 1, you are solving Roman 2. So as you solve, you are actually solving this, not this one. You should take note about the difference. Any questions about interpreting that?
Excuse.
Will you interpret? Yes, go ahead.
Excuse.
Go ahead.
Why did you put the negativity? You did not put actually greater than or equal, and then you just put greater than. Oh,
Here.
it's here. I've seen it. It's okay.
Here.
I've seen it. So.
All right. Any
Thank
other
you.
question? You're welcome. Any other question? So when you check the last question, this should be question 7. This was typing error. Also, the first Roman is to formulate linear programming model. Then Roman 2, you generate dual. Then Roman 3, you solve dual. So it will be your assignment. Let it be your assignment. You formulate linear programming model. Then you generate a dual problem. Is it clear? Just to test whether you have understood, you will try that. Now, concepts do not change. Concepts do not change. If your initial problem was to minimize, your problem should be to maximize. All of these ones, concepts do not change. Now, colleagues, I have inequalities for question 6. I have also inequalities for question 5. I am going to use question 5. At sort of linear programming model. Then you use the same knowledge to solve this. But if time allows, we can actually handle both. So let's start with this one, question 5. This is our model. This is our model. And we are to use simplex method. Whether you are using graphical method or simplex method, the first step to do is always to formulate linear programming model. Once you have that, then you will be good to go. So we are saying using simplex method, we have steps that we follow. Step 1, convert inequalities into equations by introducing a slack variables. Convert inequalities into equations by introducing slack variables. Why are you introducing slack variables? Is to remove inequalities. What is a slack variable? Just that variable will help you actually to know whether at the end of it all you have a surplus on a constraint or not. Here you have 750. We need to see at the end of it all, did we utilize this 750? At the end of it all, we need to see, did we actually utilize all this 1,500? That's why we are trying to introduce slack variable. So this was your inequalities. We are saying where there is inequality, put equal signs. First wait, colleagues, don't just copy. Then, but we are saying for you, yes, you are putting this equal sign, but you must introduce a slack variable. You must introduce a slack variable. So I can say let A be a slack variables. For what was the constraint related to inequality 1? What was here? It was direct materials. We say for direct materials, then the next constraint is what?
Direct wages.
Direct wages. And the last one is what?
Overhead.
And overheads, respectively. Then, once I do that, where there is, before I put equal sign, I introduce a slack variable. Remember, slack variable for direct wage is A, so I will add here A. Then here, I will add B. Then this one I will add C. This one is not supposed to be there. Remember the first one? Now these are equations. This is equation 1. You no longer have inequality. This is equation 2. This is equation 3. Where did we get those letters? A, B, C. A, B, C. We said that A, B, C are slack variables. We introduced slack variables. We are just trying to define the slack variables. Because we know that you cannot remove, when you're using simplex method, you cannot remove inequality minus introducing slack variables. Remember, everywhere you have inequality, it is subjected to a certain item. The item you have here is direct material. The second one is direct. When you check this side, you have direct materials, you have direct wages, you have overheads. So as you introduce slack variables, the first slack variable is representing direct materials. Then the second slack variable is representing direct wages. Then the third slack variable is representing overheads. So you can define by using any letter. You can say let slack variable be A, B, C, or you can say let slack variable be S1, S2, and S3, depending on how you want. If you have only 2 constraints, or if you have only 2 inequalities, you will only be having 2 slack variables, like A and B. If you have 3 constraints, you will be having three slack variables. Let me hope you are now okay. Are you done with copying? This is our first step. Please put some speed. Put some speed.
We are done. We are done. We are done.
Step number 2.
We are done.
All right. Step number 2, we are to form initial simplex table or table. If this casing is hard for you, you just assume it is table. And the initial simplex table, you are going in the first column, you wait. The first column is going to be your solution variable. That is the first column. Then the second column will be representing product variables. And the product variables, those are your decision variables. How many decision variables do we have in this question? We have X and Y. So you will have column for X, you will have column for Y. Then the next one is going to be a solution, no slack variables. How many slack variables do we have? 1, 2, 3. This is A, B, and C. Then the last column, here some people put column for objective function, but that is wasting a lot of time. Just put a solution quantity. Then you will just have, you will put here, this will be, we start with solution variable. Here we put this A, B, and C. This should always be your starting point, that the solution variable column, this first figure, this first column, sorry, should indicate your slack variable A, B, and C. You just copy the way they are. Then what are you going to put here? You come to your equation. What is the value of X here? Now I need we move together. What is the value of X here? It is 1. I write 1 here. Because you are dealing with row 1, you first finish row 1. What is the value of Y? 1.5. Then what is the value of A?
1.
On equation 1, do you have B?
No.
So we put here 0. Do we have C? No. Do we have a figure after equal sign? 750. That's how you are going to do. Then for this one, for next one, you come back for equation 2. The value of X is 2. The value of Y is what?
3.
3. Then do we have A here?
No.
So A will be 0. Do we have B? Yes. So B will be equal to 1 here. Do we have C on equation 2? No. So yeah, this is 0. And what is the figure after equal sign? 1,500. Then next, equation 3, this is 2. This is 1. Do we have A on equation 3? No. So
No.
this is 0. We don't have B on equation 3. This is 0. Do we have C on equation 3? Yes. So this is 1. Then the value after equal sign is 1. Solve that. And lastly, you are going to put the objective function. What was the value of x? Objective function is 500. 500, but keep in mind that your values or your amounts are in millions. Then for y is how much? 400. Then when you observe objective function, we don't have the slacker variables. The reason is you don't have inequality on objective function. So there is no way you can introduce slacker variable on objective function. Then here it means that you don't have A on objective function, you don't have B, you don't have C, you don't have even equals a figure after equal sign, you don't have that. So that should be your initial simplex tab.
I beg your pardon, why don't we have slacks on objective function?
The reason is you don't have inequality. Do you have inequality on objective function? There is no inequality. Remember, we introduced slacker variables to remove inequality. So here you cannot introduce slacker variable because there is no inequality on objective function. And another reason is you actually don't need to determine a surplus on objective function. It's not, your objective function is not a limiting, it's not limitation. It's not limitation. What is, your limitations are constraints. Your limitations are constraints. And that's where we expect you to be having either surplus, have you fully utilized your constraints that have your available materials, have you utilized the available workers. That's basically why you are introducing slacker variable. At the end, we will see whether we actually have a surplus or not. Any other question? Have I answered you correctly, clearly?
Yes, it's okay.
Are you done? You can copy this very fast. We continue. So step number 3. And that column with the highest value on objective. I can just put Z. If we observe on your Z, what is the column? This is the highest value. So this will be my pivot column. This is my pivot column. Pivot column. Just use your pencil and indicate that this is your pivot column somewhere. And how do you identify pivot row? You come to your solution quantity, get this figure, then divide it by the corresponding value on the pivot column. This is your pivot column, the corresponding value is 1. What do you get? You get that. Then the next, you get this figure, divide by the corresponding value on the pivot column is 2. Then you get this figure, divide by divided by the corresponding value, which is. Now, remember these values, you are just it's just like a separate working or side work. Don't again bring this this saga here on your initial simplex tablet. This is just side work using the pencil and all that. Now, from these three values, you are going to identify the lowest value, and the lowest value will give you the pivot row. So it means that this is your pivot row. One with the lowest value. We have identified the pivot column and we have identified a pivot row. Then the next step, step 4, come up with what we call row operation. Row operation is like formulas that are going to help you to make other values apart from the meeting point. The meeting point, what is the meeting point between pivot row and pivot column? The meeting point is this one. No, sorry. The meeting point is actually down here. So we want to make this meeting point to appear as 1. First formula you need to come up with, first formula, and that first formula will be on. This is like row 1. This is like row 1. This is like row 2. And this is row 3. This is row 4. So the fact that this figure is not 1, I will need a formula. I will need a new row, which row? New row 3, and it will be equal to, the row I want to change, which is row 3, divided by the figure I want to change. I want that figure to appear as 1. So for this figure to appear as 1,
Excuse.
I did, yes, please.
How do you live pivot row?
Pivot row. I said
after identifying the pivot column.
Yes, for you to identify pivot row, you must first identify pivot column. Once you identify pivot column, you come this side where you have solution quantity. Then get this value. This one divided by what is the corresponding value on the pivot column. It's 1. Are you seeing that? Then get this value divided by the corresponding value on the pivot column. Then get this value divided by this. Then at the end, observe your values here. The lowest value will give you the pivot row. 1 with the lowest value gives you the pivot row. Are you clear?
It's okay.
I feel lost. Where, please ask. I'm too slow. Just that some of you will be handling different things, but you need to be attentive. Be attentive so that we move together. Where exactly so that I can repeat for you? Someone in the chat, please. Which step is hard? Which step can I repeat? So row operation, we are saying the reason why you need this row operation is the first one. You need to make sure that on your where pivot column meets pivot row, this point, this figure should always be 1. You must come up with a formula that should help you to make this value to appear as 1. And which formula will that be? You're going to get the original row 3. This is your original row 3. Then divide by 2. Why are you dividing by 2? Because this is the figure you want to change. You always divide by the figure you want to change. If here we had 10, we divide by 10 here. If we had 8, we divide by 8. Okay, then once you're done with that, it means that you must come up with formulas that are going to help you to make this value to appear as 0, to make this value to appear as 0, and also to make this value to appear as 0. That is a rule that someone who is marking you, if he observes your next table, he must observe on your pivot column, he must observe here 0, he must observe here 0, he must observe here 0. Then the meeting point, he must observe 1. And that's what we are trying to do. So we need the formula here that can help us to make this value appear as 0. Who can guess? Who can try? Which formula can we use to make this value to appear as 0? We get the original row 1, the row we want to change. Then we subtract. Here we don't divide, we subtract. The figure we want to change, I assume it is 1. Then times your pivot row, which is new row 3. Always understand it clearly that we get the figure, the row we want to change, minus the figure we want to change, times your pivot row. Then the next row we want to change is row 2, because we want to change this figure to appear as 0. Now I need you try. Since I have done this, I need someone to tell me what is new row 2. What is new row 2? Derek, what is new row 2?
I think you get the row that you want to change, that is R2, row 2, minus the value in that row, which is 2, then times the new row 3.
The value we want to change is 2 times the new row. New row what?
New row 3.
New row 3. This one remains constant as your pivot row. Please elaborate more on row operation. If you understand this, it will be done. That will be the end of the story. Or you can repeat. I said the first step, once you identify pivot row and pivot column, the next step is row operation. You must, for you to pass this number, you must always start with pivot row. And you ask yourself, your pivot row is on which row? It is row 3. It's row 3. And since it is on row 3, you ask yourself, is the meeting point where pivot column meets pivot row, is that meeting point 1 or not. If the value is not 1, it means that you will need to come up with a formula that is going to help you to make that value to appear as 1. So what is that formula? That's why I was saying you get new row 3, and it should be equal to the row you want to change, which is row 3, divided by. Here we are dividing because we want to make this value 1. We don't want to make this value to appear as 0. We want to make the meeting point to appear as 1. So I divide by the value I have here, which is 2. If I have 5, I divide by 5. If I have 10, I divide by 10. Then you are done with that first formula. Then the next formula is to make sure that you come up with formulas that are going to help you to make this value appear as 0, make this value appear as 0, and also make this value to appear as 0. Because someone who is marking you should actually see that your pivot column, this value is 0, this value is 0, this value is 1, this value is 0. That is a rule. So that's why I'm saying we need to come up with new row 1, which will be equal to the row we want to change, which is row 1, minus the figure you want to change. The figure you want to change is 1 times your pivot row, new row 3. Times your pivot row, new row 3. Penina, I want you to now to answer this. Which formula are you going to put here? Row 2, the row you...
Be lot 2 minus
Yes.
2 new lot 3.
2 new row 3. Then we don't need to put again new row 3 here because already we have a new row 3 this side. So we go to the next row, which is new row 4. Another person can tell me what is new row 4? Let me pick one person here. Vicky, you are quiet. What? No, Mary, you are quiet. Mary, what will be your formula here?
It is going to be row 4 minus
The row you
500.
want to change.
Yes.
Minus the row you want to change minus the figure you want to change.
Then times the new row.
New row what?
3.
New row. This one remains constant. So you have your formulas, and you can come up with a second table. Second simplex table. The second table, we are going to fill it by just following our formulas. These are our formulas. So this is your new row 1, this is your new row 2. This is your new row 2. This will be your row 3. New row 3, this will be your new row 4. You just follow formula, but you see that to answer this, you must first get row 3. because you need a new row 3 on every formula. So it means that you need to start with new row 3, which is here. This is new row 3. Start with it. The formula is saying you get original row 3 divided by 2. I have here 2 divided by 2. I get 1. This is X. Oh, sorry. This should be down. Here I put X. Here I put Y. Here I put A, B, C. Then I first fill this one. I first leave out this solution variable. I am dealing with row 3. What was the value here? I get the value that was here, which is 2. I divide by, the formula is saying you divide by 2. I divide by 2. You see I'm getting 1. Then the next, I get, you must do the same on your calculator. Get this, divide by 2. You get the next, what is the figure? The value here is 0 divided by 2. You keep on doing that on your calculator. This divided by 2. Then the value on C, it was 1. I divide by 2. Then the last one, it was 1,000. I divide by 2. I am done with new row 3. Are we together? We go to now to new row 1. This one, the formula is telling us, before we go to new row 1, you see that we have 1 here, we have 0.05. So this, originally we had a slack variable here, C. It is going to change to X. Why? Because after applying the formula, you have 1 on the product variable. So that's why you are changing. Every time you apply a formula and you get 1, you change the slack variable to product variable, but you change once. You change once. So we go to new row 1. The formula is saying we get row 1 minus new row 3.
Abel,
Yes, please.
I beg your pardon on that solution variable, how you changed it to X.
Initially, before changing, this was 2. Before applying the formula, this was 1 initially. After applying the formula, after applying this formula, you see that now your y is 0.5, your x is 1. Are you getting me?
Yes.
The fact that now your x is becoming 1 and initially it was 2, then you must change the slack variable that was here to a product variable. Every time you apply a formula and you see that the product variable is changing to 1, then change the solution variable later that was here to a product variable. But you do that once. You do that once. We change once. We don't expect you to be having another x here. No. Once you write here x, that is all. I hope that one is clear. We proceed. Is it clear?
Yeah, it's clear.
It is.
Then we go to new row 1. New row 1, the formula is saying we get row 1 minus 1 times new row 3. Our new row 3 values are these ones. So you get your calculator. I need all of you, you get the calculator. Colleagues, I don't want to keep on repeating. Get your calculators. And you follow what I'm saying. So to get the value here, the formula is telling us that we get the original row 1. So what was the value here? The value is 1. You subtract, open bracket on your calculator. The formula is saying 1 times. So you write 1 times. The formula is saying you multiply by new row 3. This is your row 3. You multiply by this. Close bracket and get the answer. Are you getting 0?
Yes. Yes. We have 0.
Do this. The same steps. Get the value that was here, which is 1.15 minus, open bracket, 1 times. What is new row 3? It is this one. Are you getting 1?
Yes.
Then we proceed. Do the same. 1 minus, open bracket, 1 times. And you may find someone is not getting this, he's waiting to ask. He's not asking now. He's not getting these values. Are you done? For say I have 0 minus, open bracket, 1 times 1 times then here I have this minus, open bracket, 1 times 1 times this. Colleagues, do you have this?
Yes.
Yes.
So this one will stay as what? This is A. Then here, you follow the same steps. You follow the same steps. The saying R2, row 2, the figure was here is 2. The figure that was here is 2 minus, open bracket. You have 2 times new row 3, which is this one. And put some speed, we still have the journey, still have some started rate. We Here, y we have 3 minus open bracket. The formula is saying 2 times new row 3 is 0.5. Then for A, row 2, I have 0 minus open bracket. I write 2 times new row 3. What do I have? It is 0. So I go to the next B. What is original B? On row 2 is 1 minus open bracket. Please don't always forget that bracket. You multiply by the figure you have here. Then next, what is the value you have on C? Row 2 is 0. Open bracket 2 times 0.5. Then lastly, row 2, I have 1,500 minus open bracket. 2 times 500. Do you all have this?
Yeah, all clear.
Then here it will be, what was the Slacker variable here? It was C or B? It was B. Now, someone would ask that now here we have 1, here we have 1, here we have 0. We should change this one. Yes, I can agree with you. Can change this one if this one was a final tabule. Can change this. But if you realize that you're still repeating the procedure, sometimes we change once a product variable. But for formality also, because examiners know that some people just cram. For formality, it is always good. First change, then you see the next step. Are you having confusion? That confusion can go away by coming back to this. What I'm saying, you will not see it now. But let me just put I will explain later about this. But people fail mostly. People fail from here. Changing these ones. You may be knowing how to get all this, but changing here, some people fail. So last row 4, who is done? Someone who is done can tell me these values faster. What is the value here? The value
0.
here you get it is 0,
150.
Then what about here?
150.
What about
0.
Then B?
0.
Then C?
And that's 250.
Then lastly, we are getting row 4. Row 4 is 0 minus open bracket 500 times row 3. Row 3 is this one. Do you have that?
Yeah.
What about others?
We are still computing.
With some speed. With
Yes,
some
I have the same.
In Mama. Also, their calculators.
Godfrey, are we together?
Not really.
Hey, now you are quiet. You here. Where is the problem?
It's really substituting in actually in the formula given down. Especially like when we look at that row 2 or
This
row
one.
3. When we put like a row 1, row 2, row 4, the first figure which you put in that place of row 4, which figure do you type there?
Here. Which column?
In the formula up here, which we gave us earlier.
Yes,
When you
this
said
one.
4 minus this. Now, which figure do we put in R4?
R4 is row 4. Row 4. If you are at this point, remember you need, let's say you need this value here.
Yes.
You come back at your original initial table.
Yes.
Initial table. What was the value for row 4? It is this one. Then you subtract. Open bracket.
That is 4, open.
Well, once you subtract on your calculator, open bracket. Then you write 500 times new row 3. What is new row 3? It is here. Come here. This is your new row 3. Close bracket and you do this. You do this and see whether you are getting the same.
I'm still not okay.
You are not getting this.
In the feeding, actually, from this formula here, like the 4 out of 4, you said I put 400.
This is
from the original. You said I put 400, then minus 500.
At this point, keep your mic on. At this point,
yes,
your Y was 400, isn't it?
Yes.
Please respond. Write 400 on your calculator. Then you subtract.
Yes.
Subtract, open bracket on your calculator.
I've opened it.
Then the formula is saying once you open bracket, write 500. So we write 500 on the calculator, then multiply. The formula is saying you multiply what? New row 3. What is new row 3? You come here. New row 3 at this point, it is 0.5. So you write 0.5. Then you close bracket and press C. Equal signs. Are you getting 150?
Yes.
Do this. Do this and see whether you are getting negative 250.
I got it.
Okay, colleagues. This would be our final tabule. This would be our final tabule. But the fact that we still have a positive value, the fact that we still have a positive value on product variable, we have to repeat the procedure. For us to confirm that actually we are done is to see here on product variable to see whether we have 0 or negative values. Because we started with positive values on initial simplex tabule, If you start with positive values on initial simplex tablet, you must end with 0 or negative values on your final tablet. So when someone is marking you and say that you still have a positive value, he or she will say that this is not a final tablet. You still have a process to do. So we are going to repeat the procedure. And as you repeat the procedure, this now is like your initial tablet. Now you forget about this. And now your focus should be on this. Your focus should be on this. So look at this now as your initial simplex tablet. And that was our second step. From second step, go to third step. I want you to do that very fast. Now we repeat the procedure. We identify, because we have initial simplex tablet, this is our initial simplex tablet now. Then the next step, we identify pivot column and pivot row. What is pivot column, Godfrey? What is pivot column here? We
The
said
pivot column
column
there is the, can you scroll and I see? That is the 150.
Yes. So that will be our pivot column here. So it is here. Then, once you do that, also identify pivot row. I said, how do you identify pivot row? You click another person here. I know some of you are saying you should not. Helen, you are quiet. How do we get pivot row?
Pivot row, it's 250.
Yes. Divide by which value?
You're going to divide it by 0.
This is your pivot column, not this one. Pivot column is this one now.
Divide by 1.
So we divide by 1. Next, we get this divide
It's 500
by
divided by 2.
divide
by 2.
Next, 500 divided by
0.5.
by 0.5. Now, what is your pivot row?
It's 250.
Now you have 250. What will be your pivot row here?
I will use the first one, A. This one, the first one.
Why? Why not row 2? Why are you choosing row 1?
Because I'm saying it's the one with the lowest what? Lowest values.
Because here you have 1 and here you have 2.
Yes, that's what I think.
What about others?
I think if you come
I would,
if you meet such a situation whereby you have the same figures that are low, you select one basing on the constraint mentioned in the question in the required part.
Derek was telling you that you, in a situation where you have the same values here, what will help you to know your pivot row is to look at the required part now. The required part is taking you to which side or to which line. When you check on the required part of the question, they said that our focus should be on direct wages. So you ask yourself, what is the row with direct wages? Direct wages is in which row? This is row 1, this is row 2. So you will come back here, and this row 2 will be your pivot row. This will be your pivot row. And if you find that they are not showing you the side, then you use your judgment. You can judge just by now. As you focus, now this one still is a solution. This is A, this is B. This is A, this is B. Now you would ask yourself, are these still slacker variables? If they are still slacker variable, then you can choose any. But if you realize that you have this saga, and here you have a product variable, and another is not a product variable, then you choose where you have a slacker variable. That's where you choose. Because you want to utilize the resources available. That's why you always need to choose that. In a situation, let's say here is Y and here is B. And in this situation, you have 250, 250, 250. And you're wondering which row can be your pivot row. In such scenario, you choose where you still have the slack variable. If you have slack variables on both, and in the question they are not clear, then choose any. Choose any. But if they are clear, if they have specified the constraint, choose the row with that constraint, like what we have done. I hope I have communicated.
Network is not clear.
But let me repeat for the last time. Here we have the same values. Colleagues, we don't look at this and this. No, we don't look at this and this. We look at what we have here. If you have the same values, like what we have now, and in the question they are specific about the constraint you should focus on. Like this question, they are telling us that we focus on direct wages. Ask yourself, which row is your direct wages? It's in which row? It's in row 2. So your focus, your pivot row will be row 2. That's what I have done. But in a situation where in the question they have not specified, and you have this saga where this side you have A and this side you have B. All of them are still a slacker variable. And in the question, they have not specified where you should focus on. What you do is to use you just choose any in that situation. You just choose any. You can choose any to be your pivot row. That is, if you still have here is slack variable and here is slack variable. But another situation is you may be having these values, but when you observe on the solution variable, you may be here, you find that you have, let's say, you have Y and down you have B. Y is the product variable, B is the product variable. And in here you have the same value. In that situation, you choose where you have a slack variable. You choose the row where you have a slack variable. Because we always need to utilize that slack variable. That's why you need to choose that. Okay, okay. I believe that's enough. Any other question? This is our pivot row. Now, once you identify pivot row, get row operation now. I start with which one? We always start with that row which has a pivot row. That is the row you must always start with. So you need a new row what? This is a new row 2. Who can tell me the formula? Now look at these ones as just like R1, R2, R3, R4. And you are trying to get new row 1, new row 2, new row 3 like that. Who can tell me the formula here? Please speak up and we finish this session.
The formula is new
Yes?
is row 2 divided by, it is row 2 divided by 2.
Row 2 divided by? What is our meeting point? Pivot column is here. Pivot row is here. Meeting point is okay. You are right. It is row 2, the row you want to change, divided by the figure you want to change. If you had one here, this formula would not be necessary. Or you would just, for formality, say row 2 divided by 1. We always divide by the figure on the meeting point. Then we need new row 1. We need new row 3. We need new row 4. Who is dodging me? Bridget. Bridget, you have not. What is new row 1? Which formula?
0.
Yes? You speak as I write. Online, you have a chance to dodge you and you say network. Who is Norma? Which formula can we write here?
Row 1
Row 1.
minus 1 minus
Row 1,
1
that minus the figure you want to change.
times new row 2.
Times the pivot row, which is new row 2.
2.
Perfect. Another person is telling me the formula for new row 3. Debbie.
New row 3
Yes.
minus
You repeat.
row 3. Row 3
Yes.
minus 0.5
Minus 0.5, correct. New row 2. Correct. Then last person, gentleman. Who is in? Godfrey, you want to try?
Try. That is,
Derek,
it is
mhm.
R4
That is row 4.
minus
Yes.
the figure I want to change.
Which figure is that? This is row 4. The figure you want to change. Is what?
It's 150.
150. Then times what?
Times our constant, new row 2.
Row 2. Perfect. So you have the formulas. You can copy the table again. Yeah. This is X. This is Y. This is A. This is B. This is C. You tell me the values, and we always first handle the pivot row, which is new row 2. The technique you should apply to know whether you are going to keep on repeating the procedure is to handle the pivot row, then immediately handle the last row. It can give you the picture to know whether you are repeating the procedure or not. So I want we first do these ones. This pivot row, then the last row. Someone's telling me new row 2. What can I write here? Which value?
Have 0.
We have 0, then the next one.
1.
1, then the next.
0.
Next.
0.5.
Relatively kamuba kamanyi banaye.
B is what?
0.5.
Negative, positive.
Positive.
0.5. Next.
Negative 0.5.
Negative 0.5.
Babeera abantu babumanyi.
250.
250. Who is not understanding how we are getting these values?
18%.
Penina, kindly mute.
Penina kindly mute. N'omusajja aliko ekikyamu. Unmute.
You see, when you leave the mic on, one day you will be disappointed. Hmm? You can speak something and cause problems. Okay. New row one. Let's go to the last one to know whether we are repeating the procedure or not. Are we repeating the procedure? Let's first confirm. X, for X, we are saying we follow the procedure. Row 4, what was the value here? The value we want to change is 0 minus open bracket. They are telling us that we put 150 times new row 2, which is 0. Then we next, what was the original value here? 150 minus I open bracket, I write 150 times new row 2, which is 1. I want another person to tell me this. Please, colleagues, speak up and we finish. What is the value here?
It's negative 75.
Negative 75. Then for C?
Negative 175.
Negative?
175.
175. Then the last one?
Negative 287, 500.
287. And okay. Are we repeating the procedure? Hey, we don't have this value. What was the value here?
0.
Are we repeating the procedure?
No.
No.
No, because when you observe on your product variable, the value is 0 and the others are negative. But most of our focus is always here. You just ask yourself, is your value still positive? If you realize that it is still positive, you should put in some speed because it's an indication that you will repeat the procedure. But for now, you can confirm that we are not repeating the procedure. So, someone tell me what is the value here? As another person is working on new row 1. Another person can be working on new row 3. For new row 3, someone tell me. Come on.
We have 1. 1.
1.
Zero.
Yes.
0.
Yes.
Negative 0.25.
Then next,
Negative 0.75. Positive, not negative.
0.75.
75.
Then last,
375.
3. So it means that here you still have, when you observe this is your x, we said it will not change. Then here, here we have one corresponding to y. And this was our pivot row. And remember, this row is corresponding to direct wedges. So put here. What about here? Someone tell me the value here. Speed.
Zero.
Yes.
Zero also.
Yes.
One.
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 Another one.
Negative 0.5.
Then for C.
Say 0.
Zero.
Who is called Rose? Very quiet. You don't want your voice to appear in the recording. For C, it is what?
Say 0.
0. Then last
0.
Zero also.
Also 0. So colleagues, you can observe actually that here the slacker variable is still A. And actually where you have 1, it is always corresponding. You see here you still have here 1. And in conclusion, we are done. X, we wanted the value of X, we also wanted the value of Y. We want the value of X, just summarize. Your X is here, is corresponding to 375. So then Y is corresponding to 250. Then my slacker variables, A is 0. A is 0. When you check, A is 0. And the fact that I don't have B and C here, it means that they are also 0. It means that they are also 0. If they ask you, the question is it asking us to maximize profit? If they ask you the maximum profit, it will be shillings. What you have here, but you write it as a positive. Don't write it as a negative. The reason why it is negative, it is because We started with positives from initial simplex W. We started with positive values towards getting negative values to know the conclusion. So here it is positive 287 are 500. But remember, our loft function was in millions. When you check, it was in millions. That's how you handle. Then, but when you check this question, actually what we are doing was not asked. They just want you to get range. That is like the way they can ask you sensitivity. Godfrey, are you on?
My son,
Godfrey, are you on?
I'm on.
Yes, pay attention on this.
Yeah.
Let me see another person who had asked whether he, yeah. Simon, are you on? And this, yeah. MDC people, pay attention on this.
I'm on, but there is a time I was off a bit, but I got back.
Okay, you need to pay attention on this. You need to pay attention on this range. Sensitivity analysis. They will always show you the basis. They will always show you the basis. You must be having the basis. And for this question, what is our basis? We are focusing on what? On direct wages. That is our focus. Now, what will happen is, remember range, the range we are talking about here, they want to know, they want you to get the lower limit. Always start from the lower limit to upper limit. Upper limit. So we need the lower limit figure, we need the upper limit figure. How do we get the lower limit? How do you get the upper limit? You will ask yourself, which row is for direct wages? Which row? Direct wages.
It's
It was
row 2.
Row 2. Direct wages, row 2. It was here. When you check in the question, the first one is direct material, the second one is now. Once you know that direct wages is in row 2, what next? You come to your solution variable column. You come to your solution variable column. Move to or consider the slack variable corresponding to direct wages. What was that slack variable? We defined our slack variables and we said A is corresponding to direct materials, B is corresponding to direct wages, C is corresponding to overheads. So it means that as we stand here on our slack variable, we choose the slack variable corresponding to direct wages here. And this is the column for B. Remember, remember, once you do that, you have B here. I am going to read. I can choose, I can start to I can choose. This is B. I have this value, 0.5, 0.5, which is positive. Is it positive? Yes. Then I have another value. I have another value, 250. Until we follow together. Now, that is corresponding to what? This is corresponding to Y. This is corresponding to Y. Remember, this is a different decision variable. Also, X is a different decision variable. Now, if you want your focus to be on Y, that's why these are the figures you will pick. You come just here on the column for direct wages. That is B, like a variable B. Choose the figure you have here and choose the figure you have here. Get 250. Get this 250 divided by 0.5. This is your working. What do you get? We get 500. Once you get 500, it means that your initial, this means that the initial figure, the initial figure will increase by 500 because this value you have here is positive. If the value here you have, if the value here was, let's say, negative, we could say that the initial figure will decrease by. But if it is a positive, you say it will increase by this. So the question is, what will the initial figure? The initial figure for direct wage. That figure after inequality, what that figure was what? It was what? 700? No. 1,000? 1,500. So you come here, you say the initial figure is 1,500, then add 500. And you'll be in a position to get 200, I think, 2,000. So this is your new figure. Implying that range is from. Now compare the initial figure with the new figure. What is the lowest? What is the highest? Now the new figure will be your lower limit from this to new figure, which is 2,000. And that is your range. Is it hard? If at all your focus is on X, if at all your focus is on X, what can be your range? You again come here to your slack variable Then choose the slack variable corresponding to the constraint that they talked about in the question, which is direct wage, and that constraint is, that slack variable is B. You come move. As you move, also observe on your solution variable where X is. Now don't focus. What will help you to determine everything is actually the slack variable thing here, B. You just move in the column of B, then where B meets X, you record that value. Here it is where B meets X. It will be this one. Then the solution quantity. Solution quantity is what? This one.
$375.
375. Once you do that, you follow like the way I was doing here. You get 375 divided by negative 0.25. What do you get? Get this?
Negative 1,500.
That's what you have. Okay. Now this means the initial. This means that the initial figure will do what? Will increase now or will decrease?
Decrease.
It will decrease. It will decrease by this figure. By 1,500. So what is the initial figure? Initial figure is 1,500. Remember, the figure we are talking about is for the constraint they talked about in the question. Then we less 1,500, and the new figure is 0. So what is your range? Range, this implies that range is from, compare new figure with new figure, start with the lowest, followed by the highest. So the new figure is lower. So the lower limit is 0. It will be from 0 up to
1,500.
1,500. That's how you can handle a range. Any question? If you meet, because some people decide to work one by one, but you will meet other textbooks or what. For them, they can decide, okay, if I have done this, I can now just compare new figure with the new figure. And you find that for them, they are saying it is 0 to 2,000. All of you will be marked right according to your, basing on how on the context you are dealing with. Here you are looking at each separately. just focusing on the constraint they have talked about. So that's all. You guys who were asking me about range, that's how you handle the opportunity cost, range. Any other question? In your free time, I don't know whether you have free time, but in case you happen to get, I want you get this summary, solve it using Simplex method. Solve it. This is your equation, your problem. Solve it using Simplex method. Introduce Slack variable, form initial simplex W, identify pivot column and pivot row, then come up with row operation. If it is to repeat procedure, repeat. But I need the conclusion. Are you going to do that?
We shall try.
Yeah. Yes.
Or you want to do it in an exam?
No.
Both.
Boy, this area has taken time minus scan for Simplex. Then you also get time, more especially if you want to learn about how to form your problem, do the other last number I talked about. And that will be enough. That will be enough for now.